Increasing urbanization is not only affecting biodiversity on land, but also in our oceans. Marine urban structures such as seawalls, pilings, pontoons, and marinas disrupt, replace and modify natural habitats, influencing marine biodiversity. Especially the flat and featureless surfaces of marine constructions are unsuitable habitats for marine organisms, offering very few refuges. To counteract this trend, scientists and industrial designers have founded the Living Seawalls project. The project combines engineering and ecological concepts to improve marine structures for the benefit of marine biodiversity. The team designed panels that resemble habitat features of natural shorelines that can be attached to new or existing artificial surfaces, providing a habitat for the colonization and growth of seaweed, shellfish and other marine life. To learn more about the Living Seawalls project, we talked to co-founder Professor Melanie Bishop from Macquarie University in Sydney, Australia. Melanie is a marine ecologist focused on how estuarine and coastal ecosystems operate and respond to change. She's especially passionate about creating habitat and preserving native biodiversity in damaged seascapes through the development and assessment of engineering interventions.
What is eco-engineering and how did it inspire the Living Seawalls project?
So the word eco-engineering, as the name suggests, is really, I guess, about integrating ecology and engineering as well. And so this can entail a number of things, either using or engineering with ecological communities to provide a human function, or alternatively, to actually better design built structures and human constructions so that they're not only benefiting people, but they're benefiting nature as well. So I guess when you look out here to a place like Sydney Harbour, what you notice is that there is a lot of built structure around. So I guess seawalls, pontoons, pilings, man-made structures that are really important in terms of stabilising reclaimed land, protecting shorelines from erosion and inundation, serving recreational purposes, supporting shipping. But the problem with these structures is that they tend to be very vertical, so they have a compressed intertidal space for species to live in. And also they tend to be really flat and featureless compared to natural rocky shores. And so if you've ever been out on a rock platform at low tides, you'd know that, the spots where you see all that diversity of life are in the rock pools, the crevices, the microhabitat features. And the problem with a lot of these built structures is they don't have those protective spaces. And so I guess our program, Living Seawalls, was really building on 20 years of research, both by ourselves and indeed the scientific community around the world. First of all, documenting differences in the type of number of species found on these built structures and I guess the closest natural habitats that tend to be things like rocky reefs. And then second of all, I guess, starting to unpack, well, what is the reason that these built structures aren't supporting the same extent of marine life? And using small scale experiments, really unpacking that it was both to do with differences in material type, so whether you're building with rock or concrete or PVC or something else, but also largely due to differences in this habitat complexity. So do you have this three-dimensional geometry that provides these protective spaces for seaweeds and marine invertebrates to hide from predators, to escape the low tide, sun and desiccation. And I guess where we come in is that, there were lots and lots of experiments being done all around the world. There was this really great evidence base suggesting that if you enhance habitat complexity, you will get greater diversity and potentially greater ecological functions. But what was missing is really scaling this up to scales that might be relevant to management.
Yeah. So the Living Seawalls project here from the Harbour of Sydney then went globally all across the world. So do you see already that this project is affecting local biodiversity, and if yes, which species do it support?
Yeah, so actually where we're standing now is the site of the very first Living Seawall, and this site was installed in late 2018. And so within 2 years, we found that there were over 115 species of invertebrates and seaweeds that were colonising our habitat panels here. And we had over 36 species of fish that were actually coming in, feeding on the panels, using the panels for shelter and that kind of thing. And so a big part of our program has also been the ecological monitoring and evaluation. And so what we do is compare what is living on our living seawall here compared to or control seawalls over there, which are unmodified. They're a seawall with nothing done to them. And then also, I guess, reference rocky shores, so natural habitats whose biodiversity we're aspiring to recreate. And so encouragingly, what we found is that after only 2 years, we actually had 36% more biodiversity than our modified seawall. And this was especially encouraging because these panels started bare, and I guess the existing seawalls have in some instances decades of growth. So even after 2 years, we were already overtaking those seawalls. And we were actually approaching what was on natural rocky shores. And then what we also do with our installations is we have, I guess, various panel designs that mimic the features of nature. So they include rock pools, crevices, pits, I guess the sort of textures of shellfish reefs, etc. And what we found is that when we interspersed within our complex designs flat panels of similar age and material type, actually we're getting up to 3 times more species on our complex panels than those flat featureless surfaces.
Yeah, this is truly spectacular. Do you see any economic or perhaps even social benefits of this project already?
So the project very much started with the goal of enhancing biodiversity, but we quickly realised that actually, you know, this biodiversity has the potential to do so much more. So particularly with local government and catchment management authorities, often a big sort of objective that they're working towards is clean water. So we've found that one of the species or the groups of species that are facilitated by our panels are filter feeding organisms like oysters and mussels. And so if applied at sufficient scale and in conjunction with other methods of mitigating water pollution, certainly we expect that the panels would have a role in cleaning the water and making our harbours more livable and more swimmable. I guess the other thing we've seen is that a lot of species that are valued for recreational fisheries are benefiting from the panels coming in to feed on the shellfish hiding behind the panels. And we've actually seen anecdotally greater numbers of recreational fishers at some of our sites. So there are potentially benefits to those industries as well. And then also amongst the species that are colonising the panels are things like kelps. So they're potentially, or they are sequestering carbon, they're providing habitat to fish. And so if we can start constructing using low carbon concrete or even carbon neutral or negative concrete, and we're getting these species colonising that are sequestering carbon, we have this potential to actually turn construction carbon negative, which is really exciting as well.
Yeah, it is. And the Living Seawalls project is a good example how we counteract biodiversity loss in urban marine environments. What would you think is in general kind of the biggest threat to marine life in these urban environments?
Well, as with pretty much every ecosystem on the planet, anthropogenic climate change is a massive threat. But I guess being in these urban environments, often the signals of warming and sea level rise are exacerbated. So what we find on a lot of these built structures is depending on their orientation and aspect, they can acquire much hotter temperatures than perhaps, you know, a shaded natural habitat. You know, if you think about, I guess, walking on a hot pavement on a summer's afternoon, you know, it hurts your feet. And in some instances, we're getting temperatures on these structures that are kind of exceeding, you know, maybe in the order of 60 degrees Celsius on the rock surface. And so, you know, I guess adding these protective spaces that provide shading and moisture retention are really important. Also, I guess for these intertidal and coastal ecosystems, sea level rise is certainly a massive threat. And again, by building these hard structures that prevent the shoreline from migrating, we're really exacerbating the impacts of sea level rise to these systems as well.
Mm-hmm. Melanie, your advice for early career researchers interested in studying marine biodiversity, maybe also in urban settings, what would you suggest?
So I guess my first piece of advice would be to think broadly about the skill set that might be useful to you. And so as I've progressed along my career, I've found myself collaborating with all kinds of people, ranging from engineers to landscape architects to lawyers to policymakers, environmental managers, designers, social scientists, you name it. And so while certainly no one expects you to be an expert in everything, and certainly a good strategy is to seek out experts to assist you with things, it's good to be able to at least speak a little bit of the language of these other groups with which you might want to collaborate. And I think, the other way in which I've learnt an incredible amount is by embedding myself in some of these larger projects that are really engaged in real world conservation and restoration, and learning about how the science actually interfaces with the politics, the social science, and, these really quite complex issues that play out in urban areas.
Yeah. So I can imagine that this Living Seawalls project in particular just had the most amazing moments of field work included. Can you share one kind of very memorable moment with us?
So I guess working on built structures, we often aren't working in the most pristine of waters. They're often heavily contaminated waters, can't see a lot. And, I guess especially in the deeper areas, things like sharks are always on your mind. So, imagine our excitement where we heard these splashes and were thinking the worst, and we turned around and there was a little penguin that popped up.
That was wonderful. Thank you so much, Mel.
Thank you very much.